All right, well, welcome to Ignite. It's the last day. I think everybody survived the party last night, so thank you for being here early in the morning on a Friday. So today we're going to talk about platform engineering. We're going to talk about architecting some of the scalable systems that you have, and you've heard a number of things about platform engineering throughout the show, and we're going to kind of walk through some of those today. I'm Mark Weitzel. I'm a principal architect in Microsoft's developer division. I've been with Microsoft for a 3 years now, and I've worked on a number of things like the developer CLI, and now I'm working on the platform engineering strategy with my colleague Dan.
Hi there, nice to meet everybody. I'm Daniel So, and I'm in the Azure Kubernetes Service team.
So there's a number of things that we're going to cover today. And again, we've talked a lot about platform engineering in a number of the sessions. You know, we talked, Amanda talked about it. We've had a number of sessions about dev boxes, ADE. And we're going to talk about how all those things come together and why these are important and driving many of the business decisions and the business impact that we have. We're going to talk about this notion of start right, one of the patterns that we've seen as our customers get started in this platform engineering journey that they have, and how you stay right with policy. And Dan's got a couple of demos there. And then I'll talk a lot about self-service and some of the foundational pieces you've seen with self-service today, and where we're thinking about going as we start to, move into this platform engineering journey. So let's talk about some of the motivations that we have here. And really, this is all about accelerating developers' time to velocity. And as IT professionals, as folks who are trying to work on this central team and drive scale, there's a lot of things that we have to manage, right? We have estate sprawl as it just, more and more projects come online, our organizations grow. We have to manage cloud spend that we have. So all of this infrastructure that's running, we have to be very cognizant of costs. And also this notion of compliance that we have, compliance, security, governance, and we have to deliver capabilities faster to our organizations. And so all of this results in this complexity that's happening all the time. And I like to think this is the new eye chart, right? So I met my insurance deductible. When I get back home in North Carolina, I'm going to the eye doctor, and this is going to be the eye chart that I have to be. And it's like, oh, can you find Flux and Argo? And it's like, oh. So these are all the things that we have to deal with as IT professionals and as developers. And the result that we end up having is this inconsistency across our estate, right? And I think of these as this, sort of death by 1,000 cuts. Everything is just slightly different that we go through. And the result of that is this tension that we can have between developers who want to move fast and try new technologies, and IT who needs to make sure that, hey, wait a minute, we need to make sure that we have all of the compliance in place, all the security in place, that things are governed properly, that we have. And sometimes these technologies may be, unproven, and we need to understand the full implications of this. And a lot of times what we end up seeing is this notion of velocity, right? As we get manual processes in our organization, it really slows things down. And so at Microsoft, we're not immune to this. We've been on our own platform engineering journey for a number of years now. And there were a couple of sessions about how we've rolled out DevBox as an example across Microsoft. And so our goal really, as we think about platform engineering, is we want to build on our commercial products and then take all of those learnings and put them into things like Azure DevOps and put them into GitHub and Visual Studio so that we understand and can drive that. Because it works for us, then likely it's going to work for everybody here as well. And so what we're really trying to do, what we're striving for, is to really strike the balance between that governance and that control, and allowing teams to be autonomous and to move quickly and do that within what we like to think about as a set of guardrails. And this really is two of the principles that we see inside of platform engineering, right? This notion of self-service. And you've heard us talk a lot about self-service through this conference, right? And we'll show a little bit of that again today with Azure deployment environments, We'll show a little bit of that with dev boxes and some of the work that Dan's going to show you about how you can take some of the things that you've started with and move into that self-service, because a lot of this is building on many of the things that you have today. So when we think about platform engineering, it's not take everything you have, throw it out because there's something new and shiny. It's no, let's build on the set of principles and practices that we have that build on things like DevOps and DevSecOps. And so we like to do that in a way that scales, and we have this notion of self-service with guardrails. We want your teams and developers to be able to choose the infrastructure that they need, choose the development environments they need, choose the tools they need, and not get in the way, but allow to have those guardrails that are in place. And that helps us manage costs, that helps us discover and reuse things across our estate. We've worked with a customer, for example, in Germany. They've got a team, a platform engineering team of about 12 folks. They support 4,000 active developers a day. They've got about 10 or 12,000 total developers on their system, and they're supporting over 700 projects on their developer platform. And that's really key, because one of the things that we see is that right now our customers are sort of stitching these things together. And one of the things that we see a lot of is, you get a portal, and that's one of the easy things to look at and say, oh, I've got now a portal, my developers can come to that. But that's really just one of the user experiences that you need to think about in an internal developer platform. And really what you need to think about is delivering and building this platform as a product, right? This is one of the big shifts. So there's technology shifts that we have to think about as we build these internal developer platforms, as we establish self-service. But there's also this cultural shift of a real product team building and delivering an internal developer platform. And that's going to lead to consistency across your estate. It's going to bring security and common architecture, so you're going to get a lot of those benefits, and that's going to help you scale very quickly across. And there are a couple of patterns that we see. We see this notion of starting right, and everything is code. And when we talk about everything is code, that's not like, hey, I'm going to write JavaScript for everything. What that is treating the artifacts in your internal developer platform like a code artifact. And so you'll see things that Dan will talk about, policy as code. We've seen customers do teams as code, where they do team management and team membership as a code artifact that they check in to get. And this notion of staying right, or staying on those guardrails that we create, and there's a number of things that we'll talk about, like policy, helping you stay within those guardrails. And then we'll close the session today looking at some of the self-service capabilities that we have, and talking about how that some assembly required and some of the things we're doing to minimize that assembly. So right now I'm going to turn it over to Dan to talk about Stay Right.
Thanks, Mark. So I'm going to talk about some of the approaches to accelerate time to value of an internal development platform. We're going to look at starting right with best practices. We're then going to look at staying right and to ensure that those practices don't change over time. So here it's really up to you to choose your own adventure. For example, I have some customers who don't actually deploy that many resources, so their focus is on staying right. One of the things that we've seen with the Everything as Code approach is that it's really powerful for infrastructure, policy, and teams. And it provides the foundations for automation, enabling self-service, and the move towards GitOps. It has multiple benefits. Once you can get your code into a repository, you then get auditability, approval, and this single source of truth. But the reality is you may actually not have time to get to all of these benefits and features. And also, this is not a single product. If we start by enabling automation, these are some of the options for an ops person within a platform engineering team. First of all, you can use a push-based deployment where you can essentially enhance your existing investments. So taking the templates you have, whether they're Bicep, ARM, or Terraform, moving them into a repository, and then combining them with an automation pipeline, such as Jenkins or GitHub Actions or Asdo. And here, you can also, or here you really get started with that automation, that single source of truth. but what you don't get is drift detection, and you still have some of these really large wieldy templates that are hard to read and hard to debug. A new approach that we see is cloud-native infrastructure as code with GitOps. So what do I mean by GitOps? GitOps is an extension of DevOps, and it's a set of practices where desired state is expressed declaratively, desired state is stored in a way that enforces immutability and versioning. It's where software agents are automatically pulling from a source, and software agents continuously observe the actual system state and reconcile. Here you have a management cluster, and you combine the GitOps agents, whether it's Flux or Argo, which are some popular open source tools, and you combine it with cloud-native infrastructure as code tools, such as Cluster API, Crossplane, or Azure Service Objects. The ones you actually choose really depends on what your requirements are. They range from just deploying Kubernetes, to deploying resources in Azure, to deploying resources across multiple clouds. However, one of the downsides here is that you need a management cluster, and you also need some Kubernetes experience. But this does also support some really great features. For example, in a single template, you can describe your application as well as your infrastructure. You can also look at some of the advanced features of deploying multiple resources and define them as a single resource, and you can RBAC a lot of these resources within Kubernetes. But what if you're using a shared application Kubernetes cluster? We have some customers who host multiple applications on a single Kubernetes cluster, and they're not deploying one-to-one application to clusters. Here you can follow a pattern using the GitOps approach. So what you would have, you could have a shared cluster repository, and this would contain the metadata for the cluster configuration. You would install a GitOps tool, such as Flux, and then you'd have Flux with a configuration that's constantly polling the repository from configuration and applying it. So in this case, the operations person within the platform engineering team would onboard a new development team by creating a PR for some isolation, such as creating a Kubernetes namespace, maybe with some resource quota. They would raise that PR, and then the Flux agent would pick that up and then apply that into the cluster and create the namespace. They would then raise a second PR that would create the Flux configuration to synchronize the dev team's repository to the namespace. And one thing I really want to call out is, here in this approach, because you're using a GitOps approach, all the configuration, the agents are on the cluster itself. So rather than having push-based pipelines where you're having to create a pipeline, grant access, whether it's communication access through firewalls or permissions, here you're just adding a configuration to these to Flux or Argo, and it's a highly scalable way of adding configurations to a cluster. And then obviously, lastly, the dev team would interact with the repository. So we've shown you some management with infrastructure as code tools, but how can you enforce governance and security and best practices at scale? If you want to allow dev teams to self-service, how can you do that and be confident that they're not going to be blowing budgets and they're not going to be breaking or exceeding guardrails that you have in place? This is where Azure Policy comes in. Azure Policy provides active control and governance at scale for your Azure resources using Deep ARM integration. And this is really nice. So with an Azure Policy, you have a couple of types of policy. You can apply policies to actual Azure resources. So in the case of, say, Kubernetes, you could have a policy that defines that certain resource tags should be deployed with the Kubernetes cluster. You could also have policies that define how many nodes are deployed with the Kubernetes cluster. There's also other policies that you can have. You can have policies that are applied inside the Kubernetes cluster. So an example of that could be, I could have a policy that enforces that I should not use external load balancers, or a policy that enforces that I only use container images from a certain repository. And there's multiple here. You can see them online. The other benefit is that you can run compliance reports across your Kubernetes clusters or the resources that you have policies. Now, you're going to see me use policies, you're going to see me use the portal, but once you start having multiple policies, you really want to have policies as code. You want to manage the lifecycle of those policies, gradually roll them out, and handle the remediations. You also may want exclusions or selecting the policies to apply to certain resources. Lastly, policy has integration with Azure Resource Graph to analyze compliance data, notifications with Azure Event Grid, and also integrations with Defender, and you're going to see that in a demo shortly. I'm going to show you a demo now of starting right and staying right. So here I'm going to show you how a platform engineering team made up of multiple personas, such as ops, observability, security folks, have enabled a basic self-service platform. So the developers can go and create an AKS cluster that they can deploy their application in the sandbox and do some testing. The developer here will be able to deploy their own AKS cluster, and they'll have the tools and also be able to deploy their application. So they'll have the tools such as the monitoring tools for metrics and logging. And then the platform engineering teams will have access to tools such as Defender and also Policy to review the compliance. So what am I actually going to show you? Well, first of all, I'm going to show you a template catalog that's already been set up by the ops team. And this is a central repository of some Terraform templates. Then what's going to happen is the developer's going to come along, they're going to pick the template they want, modify a couple of properties, and then they're going to raise a PR into the infra-config repository. And this has all been set up in the background by the platform engineering team. It's going to be deploying into a specific resource group, and they've already set up things such as log analytics workspaces for all the monitoring. So once the PR is gone in, GitHub Actions is going to handle the automation, and it's then going to create the cluster. It's going to then also deploy the Flux agent and connect that to the dev team's application. In the background, Azure Policy is going to kick in. It's going to be deploying Defender, or ensure Defender's there, and if it's not, it's going to be deploying Defender. And then it's also going to be installing the Prometheus agent, so we have metrics, container insights, so we have logs, and it's also going to be ensuring that there's some other configurations are pushed down too. Any other clusters that get created will also inherit these policies. So let's take a look and have a look at the demo. Okay, so what I have here is a GitHub repository, and I've got this catalog that I created, and if I'm the developer, I can come in here and I can look at some options that I have. And here I've got this Terraform template that describes a Kubernetes cluster, and as the developer, I'd only need to change a few properties here, such as cluster name. I'd also update the tags, who the owner is, the environment, and then lastly, what I would do is I would put in the GitHub repository for my application. So what I'm going to do is I've already got one that's pre-canned, and I'm going to copy that, and I'm going to deploy it. So now I'm just going to edit this, the config. And I'm going to commit that. And now what's going to happen is that GitHub Actions is going to pick it up. And what I've got is here, I've got a GitHub Actions workflow. Sorry. And this workflow essentially does two things. It does the Terraform plan and apply. And this example actually got offline and online, and I'll make it available to you in the collateral after this. And essentially it just does a Terraform plan and apply. That's all it does in the runner. And then also what I've got is here another workflow that runs I think it runs every night, and it does a Terraform drift detection. So now that's running in the background, what I want to show you is the actual cluster itself. So this is one that I've already created, so we don't have to wait. And essentially when this was created, I've got all these policies that are applied to it. So I'm going to take a look at those policies. Here what you can see is I've got a whole bunch of different policies that I've created for this Kubernetes cluster. And you can immediately see whether I'm in compliance or I'm not in compliance. So an example of some of these policies here is that I've got one that are requiring different tags. Or I've got another one above it that ensures that Defender is there. So you can have different policies. Policies can be in audit mode, so they're just going to check whether something's compliant. You can also have them in deny mode. And you can also have reactions, so deploy if not exists. So here, this particular one that's checking if Defender is installed. If it's not, it's going to install it. I've got some other policies here that are going to ensure that Container Insights and Prometheus is installed. And then lastly, I've got some other policies up here. If I take a look at these, you have the assignment, and I can check that out here. So the assignment is what I'm applying it to. So ultimately, I'm applying it to the resources in this resource group, and then it's backed by a definition. So the definition here, if I zoom in, is basically just ensuring that there's a tag on that particular resource. And you can see here, I'm compliant. I've got some other policies where I'm not compliant. So here, should Kubernetes clusters use internal load balancers, if I click on this one, this will actually is telling me that I'm not compliant. And if I click on the details, it shows here that this particular application is using an external load balancer. This is only in order-only mode, but if I wanted to actually stop that happening, I could put the policy into a deny mode. Now, when the developer actually deployed this cluster with their application, what they actually found was that their application wasn't working correctly. Now, we can't assume that developers have access to the portal, but the platform engineering team ensured that we have Container Insights, we have Prometheus, so all the logging is all flowing back to a pre-configured log analytics workspace. And also the platform engineering team made available some managed Grafana dashboards. So the dev team noticed that app wasn't working. So what they did was they went and checked out this Grafana dashboard that shows the GitOps configuration for that particular cluster. And what this does is here, although it's showing it for all clusters, it actually shows they're in a compliant state, but at that time they weren't in a compliant state. So the Flux job or the GitOps job had failed to apply the application. So this then led them to say, well, how can I troubleshoot this? How can I find out why my application didn't deploy? Well, because they have access to the Log Analytics workspace for this, they could then go and run a query using Azure Data Explorer that's hooked up to the Log Analytics workspace. And when running this query shows me the actual error that's coming from the Flux agents that are running on that cluster. And what you can see is here is that we actually have an error that, or we can see, come back. We can see we had an error that's showing that the application couldn't be deployed by Flux because it exceeded the quota limit that I'd placed on it. The developer could then go and fix that and resolve the issue. So using the logs that are made available to it and that have automatically been configured on that cluster they've created is really powerful. The developer hasn't had to think about it. They didn't need access to the portal directly to get access to that data. Then the developer would need access to the metrics. They're going to be doing some performance testing of that Kubernetes cluster. So here they have access, and they can see the metrics of the cluster, such as the CPU usage. They can drill into their pods, et cetera, and see more details there. Now, lastly, when I spoke about infrastructure as code, I also mentioned that I could have done this using GitOps with a cloud-native infrastructure as code tool. So if I switch back to that, I also have another repository here. So similar in the way I showed you the one at the beginning using Terraform, this is another one. And here what you can see is this is just basically a Kubernetes Helm chart, and this is defining a cluster, very similar to the Terraform one that I showed you in the beginning. And this is, like I say, just a basic cluster configuration. And then what I've got is here, I've actually got Argo running on this management cluster. And you can see here that it's deployed a resource group and a Kubernetes cluster, and it's showing me this visually. If I want to add another cluster, I can do this in the same way. I can just use my configuration, and I can update this repository and deploy it. So I'm going to do that now. And again, this looks very similar to what I did with Terraform, except this is using a management cluster. It's using GitOps. And we're going to commit that change. And then what you're going to see is in a minute, you're going to see, here you go, the Argo agents have already picked it up, and they're now starting to synchronize and trying to create that cluster. So now let's go back to the slides, please. So what you saw in that demo, you saw how I used policy to ensure that the cluster was deployed with the observability tools. It also had Defender installed, and the developer could get on and start working with their application. Now, I had multiple policies there. Realistically, I can't manage my policies when I start scaling up. You know, if I've got multiple policies, I need to be really careful. I could actually break deployments with policies. I could break new deployments with policies. So here, you really need to start thinking about policy as code, where you have your policies stored in a central repository, and then you can gradually roll them out. You can have some sort of version control. You can do some sort of automated testing. And this is really to reduce the amount of time that you're doing this through the UI and also make it more robust. So let's go back to the demo. And what I'm going to show you in just a second is I'm going to show you how you can deploy a policy using policy as code. So let's have a look. Actually, can we go back to the slides, please? Sorry, let me just go back there first. So what we're going to do is I'm going to show you how you can do an assessment. And I'm going to use an Azure Resource Graph query to just do an assessment. What I want to do is I want to deploy a policy that is going to limit the number of nodes that I can deploy with my AKS clusters. So we're going to do an Azure Resource Graph policy. Then what we're going to do is we're going to create the policy, and we're going to test it, and then I'm going to roll it out in an audit mode. I want to use a policy that is basically just going to tell me the compliance. So I'm going to confirm the compliance twice. Then what I'm going to do is I'm going to review the audit, and then I'm going to update the policy and put it into deny mode, and actually then stop any more Kubernetes clusters being created with a large amount of nodes. I don't want to blow the budget. So if we can go back to the demo, please. So what I've got here, I've already gone ahead and I've created this policy definition. And this policy definition here, this is just restricting the number of nodes I can deploy with an AKS cluster. If anybody's thinking about using this, just be careful, because this only works on AKS clusters with a single node pool. So this has already been created. And then what I've got is here, I've got some policy assignments. So remember I said at the beginning, you have the policy definition, and then you have these policy assignments that are actually do the assignment of the policy. So I've created a policy assignment, and what it's going to do is it's going to deploy this policy with audit mode, and it's going to deploy it out to some regions. Then in addition, I've also got another assignment here that's going to do a deny assignment. And what you can see is here, I'm going to be overriding that policy effect from audit to deny. Now, I'm using GitHub Actions to do that rollout. And if I have a look at the GitHub Actions, let me show you that. You can see here, I've got a workflow. And this workflow is essentially going to deploy it out to the different regions. So first of all, I'm going to deploy it out to region 0, which is West US 3. Then I'm going to deploy it out to West US 2 for ring 1, and then ring 2. So let me show you what that looks like. So I've already gone ahead. The policy has already been rolled out by GitHub Actions. And this is showing me the compliance. And you can see here, I've got a number of Kubernetes clusters that are already in West US 2 and West US 3, and at the moment they're all compliant. And what I didn't show you was the Azure Resource Graph query. Here, when I ran the Azure Resource Graph query, I only have all my clusters are less than 6 or equal to 6 nodes. So those are all fine. So now I'm in a position where I'm pretty confident. I ran my Azure Resource Graph query. I'm equal or less than to 6. I've also gone and run the audit. The audit's come back clean. I haven't got any clusters that are greater than 6. So now I want to switch the policy into deny mode. So what I did was I've already gone and rolled that out to the first region, which is West US 3. And if I view the compliance, well, there won't be any problems because everything is compliant. Now, how do we actually know that this policy is doing its job in West US 3? Well, obviously, prior to coming to this demo, I deployed a cluster with Argo and Cloud Native infrastructure as code tool. And if I actually go back and have a look at that and click into it, you can see that I've tried to deploy this cluster 401. And if I drill into the events, you can see that it actually failed. And it failed because it was disallowed by policy. So the policy that I just showed you was blocking clusters that have more than 6 nodes. And if you actually, for those who are watching keenly, you can actually see I tried to deploy a cluster with 7 nodes. So the policy has stepped in and prevented that cluster being created. Cool. Let's go back to the slides. So security. So security is a multi-layered approach from code, container, cluster to the infrastructure. And Microsoft has the tooling to support this with capabilities across cloud and edge. Starting with the code, you have VS Code, Visual Studio Code with security extensions. You have GitHub Advanced Security with features such as sensitive credential detection, security dependency scanning. And to support DevSecOps, we have Defender for DevOps, a service that's available in Defender for Cloud that empowers security teams to manage DevOps across multiple pipelines, including GitHub and Azure DevOps. There's a wide range of workload protections, so I'm going to talk about Defender for Containers. This is a cloud-native solution that's used to secure your containers, helping you to improve, monitor, and maintain the security of your Kubernetes clusters, containers, and their applications. And this supports environment hardening. So Defender for Containers can continuously assess and provide visibility into misconfigurations. It can review guidelines and share those with you and help mitigate identified threats. And also, these clusters can be within a hybrid environment, or they can be across multiple clouds. It also can do things like vulnerability assessment, so it can check in with the container registries and review vulnerabilities there, as well as do runtime threat detection for Linux loads and clusters, generating security alerts. And you're going to see some of this in a demo in a minute. Let's also talk about cloud security posture management. Here you can have an inventory of all your resources across AWS and GCP, identifying risks such as attack path analysis, so understanding the potential routes an attacker may take. You have Cloud Security Explorer, where you can proactively identify security risks by running graph-based queries, agentless scanning, data-aware security posture. And not forgetting cloud infrastructure entitlement management. Here we have Microsoft Entra, formerly known as AAD, supporting multi-factor authentication, role assignments, permission management at scale with unified access policies, providing visibility and control of resources in Azure, AWS, and GCP. And all of these are integrated across your cloud infrastructure, whether it's to discover and classify and prioritize weaknesses in cloud, SaaS, IaaS resources with external attack surface management with Defender ESM, or whether it's with unified data governance solution with Microsoft Purview. And there's also a zero trust approach to perform network segmentation and apply intelligent threat detection with Azure Network Security. And lastly, we have security information and event management with Microsoft Sentinel. So let's go back to the demo and let's have a look at security. So here we have Defender for Cloud dashboard. And what I can do is I can see all my resources. At the moment, I don't have anything deployed in other clouds, but if I did, I could see them there. And what I want to do is I first of all want to go and check out the Azure Container Registry that my application was using that the developer deployed. So I'm going to take a quick look at that. And if I do a search for that, here I can see that it's gone and reviewed my container images, and it's telling me that I've got some container image vulnerabilities. And here it will list out all the ones that I have, and you can see my containers aren't in a good shape. I've got multiple CVEs on these containers, and I can drill into these. It's going to give me more details and help me mitigate those and what I need to do about it. And here, this is actually affecting my application DB. So that's showing you the container registry. If I go back and I have a look and let's take a look at my AKS cluster, AKS 001, and see if that's in a better shape. And here, obviously, it shouldn't be a surprise to us, it's not in a better shape. Defender for Cloud is actually doing a runtime assessment of the cluster, and here you can see that I've got a lot of different high severity issues that I should go and take care of. And if I actually look, I've got, again, vulnerabilities here of the running containers, and that's no surprise. The images were vulnerable in the registry. They're going to be vulnerable when running on the actual Kubernetes cluster itself. And so here, as a security person, I can review these and then start working with the dev team or the ops team to go and remediate these particular vulnerabilities. The other thing that's really cool is that we have this advanced threat detection. So Defender for Cloud can take or can review the logs coming from the server and then check for suspicious activity. So here what it's done is it's telling me that I've actually got some suspicious activity, anonymous access to a Kubernetes secret. And here if I drill in, I can actually look at some of the details. And basically what it's detected was in the log analysis that the way a secret's being requested isn't normal. So this could be a bad actor or something that shouldn't be happening. And it will give you steps to remediate that. Lastly, what I want to show you is that we have attack path analysis. Again, this is a really cool feature. If I review my attack path analysis, I can see that we have an internet-exposed Kubernetes pod that's running a container with high security vulnerability or severity vulnerabilities. Well, that shouldn't surprise us based on what we've just seen in the other reports. And this will show you all the components that are involved with, with a deployment. And you can see here that this is the registry that I just showed you. It shows you the app container, it shows you the pod, the Kubernetes cluster, and all these different pieces. And it will show you how to resolve this and what that means. So it's, this is a really powerful thing that you can do. So if we switch back to the slides. Sorry. So you saw me do security. I just want to say a few words about cost management. So subtly, as we've been talking through the demos, you've seen me enforce things such as resource tags to do ownership. You saw me use policy to restrict the resources or the properties of the resources on AKS. You can use policy to actually say, I only want this person or this person or system to only ever deploy this resource. But you also have Azure budgets. So for those of you who haven't played around with it, you can use Azure budgets to actually define a limit of budget on a particular resource group. So I actually have a limit on my resource group, how much I can spend, because I don't want a conversation with my manager why I'm consuming a lot of money on my subscription. And you can put alerting on this as well. And then lastly, I'd like to also talk about, we've just released AKS cost analysis. So at the beginning, I told you that a lot of customers use shared app Kubernetes clusters. This gives you a way of being able to break down the cost of all these individual apps running on a shared cluster. Lastly, what you may end up with is a lot of Kubernetes clusters. This could be because of scaling limitations, resilience, different environments. And so how do you manage those at scale? Whether that's to upgrade them or whether that's to orchestrate workloads. And here we have AKS Fleet Manager. And this just recently went GA, and the GA features allow you to do things such as upgrading your fleets in a safe and scaled manner. And so, for example, you can slowly roll out Kubernetes upgrades across development environments, wait a certain period of time, then to staging, and so on and so on. It also allows you to distribute workloads over your clusters. So you can distribute a workload to a hub cluster, and then it will move it based on certain properties. For argument's sake, if you pass in a label that says this needs to be in East US, the hub will then just move it to a cluster transparently in East US. So just a quick recap there. You saw policy and governance in the self-service platform. You saw how it integrated with the automation and the templates and how we enforce standardization. You saw me use policy as code, where I safely rolled out a policy. I did the Azure Resource Graph query, I put it into audit, and then I switched it to deny to ensure that people weren't deploying these really large Kubernetes clusters. You also saw me using different cloud-native tools, such as Argo, Flux. You saw me using a cloud-native infrastructure as code tool. And then lastly, you saw the security piece of this. Obviously, everything was there as code, providing the centralization and standardization, and everything there was actually multi-cloud. Even Azure Policy can work across multiple Kubernetes clusters, across multiple clouds. Azure Security does, and also the infrastructure as code. I'm going to hand back to Mark to talk about some self-service environments.
Great. Thanks, Dan. So one of the things that we've been talking about now is a lot of self-service, and you saw that there was that some assembly required. I can actually take that same infrastructure that Dan was talking about, and if I'm using something like Azure deployment environments, I can bring that into Azure deployment environments as well. So I'm going to switch over here to my screen and quickly just show a little bit of Azure deployment environments and dev boxes. So here I went to the devportal.microsoft.com. I have my deployment environments. You can see my dev boxes here, and I have some deployment environments. What's nice about the self-service is you saw a lot of the kind of cut and paste that we had to do earlier. If you use deployment environments, you can actually create all of that infrastructure very easily by creating a new deployment environment here. So I'll just call it MDW Demo 01. And there's this notion of projects inside of deployment environments that allow you to organize. And you can see here I'm actually part of multiple projects here. So here's the Tiger Team 1, and here's the dev. Now what's nice about deployment environments is some of the things that Dan has to deal with in all that cut and paste is what subscription I'm using, what resource group I'm using. All of that kind of gets in my way as a developer. There's a lot of infrastructure as code that I need to learn about. So in this case, I don't need to worry about any of that because deployment environments kind of wraps that and keeps that from my, I don't have to know all of that. And here's the Kubernetes Flux example that Dan was looking at. So I'll do that, and I'll just go ahead and create that as well. And Sagar, who is the PM for deployment environments, and Anthony did a great session yesterday on deployment environments and dev boxes. And so if you haven't seen that, catch the replay. But here's one here that I've done also. And we talk about a lot of context switching. And developers have to use a lot of tools. I work on multiple projects. Like, that can be a lot to do all of that context switching. And so using the dev boxes, I can have a dev box set up for that Tiger team that I had or that eShop that I'm working on. And I can have the same infrastructure set up as well. So here I've done a couple of things where I have the eShop now set up because I'm working on a particular issue. And I can hop over to a dev box, and I can bring up that here, and I can quickly have all of that set up for me. I can have the Visual Studio set up and ready to go, and I can simply take that environment that I just created inside of the dev portal, and I can bring it in and pull in the values here. So if I look at AZD, env, get values, those are all the things that I need. And you can see I don't have to worry about things like the resource group or the subscription. It's just all done for me. So that's really nice self-service capabilities. So now let's flip over to the slides again. And if we think about some of the things that we've just done, like, there is still a lot of assembly required, right? We talked a lot about infrastructure as code and policy as code, but you're using a lot of tools inside of there. Your repository has to be set up. Your pipelines need to be configured. You might be using ServiceNow for your ticketing system or your support system. You might have things like a Slack channel that you have to set up. So when we think about platform engineering and this assembly required, we think about that holistic picture that we have. And so we're working on a prototype of what we call a developer self-service foundation, which is going to be an extensible API-driven layer. that will sit on top of these templates, like the Start Right templates that we talked about, and we'll be able to orchestrate all those behaviors across a set of providers that we call. So things like GitHub, things like Azure DevOps. And you'll be able to invoke or interact with that API layer across any of the developer experiences you want, whether it's a portal, the CLI, or even Copilot. And that will all drive your app platform and your engineering systems. So that's where we're going, and that's our vision. Whoops, lots of clicks there. And so wherever you are in your platform engineering journey, we'd like to learn about that. We'd like to share our experiences and learn from you so that we can make this better. And you can see some resources there, and there's a QR code that you can click and get those resources as well. So thank you very much. I hope you had a great Ignite, and hopefully we'll see you next year.